Okay, thanks. I'm not going to talk about public goods. I'll try to say something at the end very quickly. But I'm going to talk generally about what I call asking the brain, a series of studies that happen to all use functional brain imaging, but many of these the things I'm studying could be used, you could use much cheaper, more portable tools as well. And I picked out a kind of smorgasbord, a tasting menu of studies that I think are basic research, because that's my interest. I haven't been involved in the thrilling rocket ship takeoff of applied nudge-type research. So this is still quite basic research, but it has to do with behavior change, understanding why people do things. So there are two informal slogans often used in neuroscience. One is called, don't ask the person, ask the brain, or you could ask both. What that means is that people may not voluntarily want to tell you why they do what they do. They may not know. It's sort of inaccessible, we say, in neuroscience, or unconscious. Second slogan is, if the behavior is interesting, the brain activity will be interesting. So usually we start in behavioral economics, in neuroeconomics, with something that's a bit of a puzzle from the point of view of standard theory, like why don't people take free smoke detectors when the science evidently tells them it might save their lives. And then we try to understand the behavior pretty well and then go in and see what's going on in the brain to help us see the mechanism. So today I'll talk about, due to lack of time, I won't talk about public goods except just to give you a teaser. That's been a published paper you can read about. But I'm going to talk about why people really do things. And they may actually do them differently than they say they hypothetically would or they imagine they would. And I'll focus on buying and smoking quitting and also sunscreen application, very, kind of somewhat mundane things. But you could also apply this to voting and donating. Those are the things where people say, oh, I plan to vote. Not as many people vote as say plan to vote. In fact, they also recall having voted more often than they really did. Just like all the people who saw the Rolling Stones concert here. There probably are tens of thousands who said they were here, and actually it was 720. And the same with donations. So apparently even among nations, when there's a horrible tsunami in Indonesia a few years ago, nations around the world pledged quite a bit of donation, and then the actual amount that gets delivered is usually less. So we want to understand why these things happen. Okay, I'm going to start with real versus hypothetical behavior in three domains. One is good foods and then yucky foods, and the second is pain or money. And there are quite a few other domains similar to this, typically involving moral trade-offs or new products. And the idea is that in many cases in marketing research and in science and in opinion polling, we're going to ask people what they would do in certain situations, or what they would major in college, or are they planning to go to med school, but we're not going to actually hold them to it. So I'll call that hypothetical behavior or imagined behavior. And again, what you find is people say they're going to do things more often than they actually do them. And one example is vices and virtues. So people say, oh, I'm going to go to the gym, I'm going to go to the gym. Starting January 1st, I get a new gym membership, and I go for 3 weeks, and that's it. And so the way we've attacked this, me and Dean Mobbs at Columbia and others, is to say, let's actually put people in situations where they sometimes make hypothetical choices, and then usually we surprise them, or we have two separate groups of people, and we have them make real choices. They're going to either have to eat the foods they may find a bit disgusting, or they're going to have a chance to buy consumer products like a mouse, electric mouse, and then see what they actually do. And we're going to see whether the same brain areas have activated. It's possible, by the way, that when people are making these hypothetical choices, they really are thinking very, very carefully, and they're making a plan, and they are going to stick with it. Or that there's some people who do that. And if that's the case, we would see kind of perfect overlap in brain activity. Another possibility is that they're over-reporting their plans. Oh, I plan to vote. Oh, yeah, I'm going to donate. Oh, I'm going to major in computer science. Oh, I'm going to go to grad school. Oh, I wouldn't harm that person in order to save money. But when push comes to shove, they don't do those things as much as they want. And then we might see differences in brain activity that would give us a clue about what's going on. So that's the idea. Okay, so the first study was done a few years ago with Min Kang, Antonia Rangel, and Michael Camus. This is one example in the lower left. We showed people this backpack. In the first phase of the study, there's 4 phases, as you can see in the center. First, we give them 200 different consumer goods, and we say, how much would you pay to buy this? I mean, try to be honest. Like, if you don't like it, just say, I wouldn't pay very much. If you really like it, say you pay much. And so for the backpack, for example, they have a little slider scale. People might say, oh, I'd pay $30. Then we put them in a brain scanner. We're going to record where blood flows into different areas of the brain, try to see what those regions are computing or kind of encoding in a mathematical sense. And we ask them first for 50 trials to make hypothetical purchase decisions at a price that we pick based on their original report. So we may show them the backpack and say, you know, if you could buy this for $22, yes or no, would you buy it, yes or no? And we also ask them, are you strongly sure you would buy it, or just kind of weakly? You know, like a strong yes, a yes, or a weak yes, yeah. And the same with no's. Then we stop and say, oh, by the way, we didn't tell you this before because we didn't want to spoil the surprise scientifically. But now we're going to have you actually make purchase decisions, and one of these is going to count. We're going to pick one of these at random. And if you say, oh, yes, I would buy the optical mouse for $18, if we choose that at random, we're going to actually make you pay us $18, and we have an optical mouse we're going to ship to you through Amazon delivery. So if you really don't want to buy, you know, just say no, and you won't have to get stuck with anything you don't want. And we give them money initially to pay out of, so that even if they pay $18 for the mouse, they have some money left over. And then after the scanning is over, we do another thing called surprise real purchase decisions. And there we ask them about the ones they gave hypothetical decisions for in the beginning. So we ask them again about the backpack. And then we can see, you know, of the people who said, oh, I would definitely buy the backpack for $22, do they then buy it? Or they say, nah, I changed my mind. I was kind of just playing along, or I thought it was being helpful. It's sometimes called yes bias or acquiescence bias. I thought you wanted me to say yes, even though we tell them to be honest. Okay, so the first thing is, this is a bit of a complicated graph. Look on the right side. In the categories of weak yes and strong yes, those are where people said, yes, I would like to buy it. The blue bars indicate the number of people in the hypothetical condition who said, yes, I'd buy it. And all you need to see is that the dark blue bars are higher than the surprise real and real bars. And it's basically about 60% of the people say, yes, I'd buy, hypothetical. And when they have to actually buy, and they know that one of their decisions will actually be chosen, it's down to 40%. So there's quite a bit of over-reporting of purchase intentions. And again, you see these patterns in voting and donation and lots of things. Okay, so now we want to understand what brain areas are being used in these two decisions. Probably the brain areas don't overlap because the behavior is really different. There's a lot of yeses when they don't have to really pay, and then fewer yeses when they have to shell out. And so fortunately, you can show this, the areas of differential brain activity in a pretty nice simple graph. Basically, I've plotted in yellow the areas that are statistically significantly above the baseline in real decisions, averaging across everybody. And there's regions here, you don't need to understand the acronym, but some of them will pop up later. The forward part of the brain is called medial orbital frontal cortex, orbital frontal from the orbital eye sockets. Then there's a region called anterior cingulate. We think of that as an area of executive function. If you're trying to make a difficult decision, my colleague John Ullman said, I asked him once, what behavior activates anterior cingulate most strongly? He knows a tremendous amount about that particular region in apes and monkeys as well as humans. And he said, trying to keep from going to the bathroom. So if you have a deep biological urge and you're trying to suppress it, you will see that area activated. You also get it in something called a Stroop task that some of you may remember from college. So if I showed you a bunch of words printed like black, blue, green, and printed in different ink colors, like I show you the word black printed in red, and I said, don't tell me the word, tell me the ink color. Most people have a hard time, they'll read the word out. So if black is printed in red, you'll say black, because you're much better at reading words than naming ink colors. That's called a Stroop task. Or I don't know if you have this in the UK, but in the US we have Simon Says. You get a bunch of motor instructions, touch your head, Simon Says, touch your nose. Simon Says is a Stroop task. So when kids are doing that, this anterior cingulate region is activated. And also an area called midbrain, which is the source of dopaminergic. Some of you know what dopamine is, dopaminergic neurons that project to other parts of the brain. And so in red is the hypothetical areas. Those are the areas that are activated more by hypothetical. So you get a very nice simple result, which is, if you're making hypothetical decisions, you're using part of the brain circuitry that you use to make real decisions, right? It's perfectly located in the center, which is cool, with maybe just a little bit of exception in the middle, ventral striatum, VSTR. But in addition, the areas that are being used for real decision-making are much broader and more statistically strong. So a hypothetical decision-making is literally kind of a subset of real decision-making. And this gives us a clue about also what you might do. We have not done this, and I don't think it would be that difficult to do, but it would be work, a year or two of academic work grinding away. But what you could do, for example, is to say, I could look at somebody's brain and say, we kind of know what brain circuitry should look like if you're making a really serious decision that's consequential for you. And even though we asked you this hypothetical question about whether you would want to be treated with whether you would want to what your end-of-life treatment might be if you had a terminal disease like a cancer, or whether you're going to commit to stay in the Army for 5 years or something really serious. We could then look at your brain making this hypothetical decision and say, I think you're taking this decision seriously because your brain activity looks like somebody who's really serious, i.e. yellow here. So in principle, you could start to kind of de-bias the tendency of people to say, oh, I would do it, when we know that they're probably over-reporting on how much they'll exercise and all these other things. Next step, we wanted to now explore bad foods, or what's called public bad. So this is less of a topic in conventional marketing. You're trying to sell consumer products or practices, but you might also be trying to, to sell a kind of a bad, or to get people to, for example, Jazz Groom I met earlier said he was in a pig abattoir in Malaysia trying to get people to wash their hands because they get very dirty if you're slaughtering pigs. And so you could also equally ask, if you were human resources director, how do you get people to work in a pig abattoir? Obviously, money is one thing. So another thing we're interested in neuroscience is not just good things that happen to people like rewards, but aversive things that create punishments, right? So how do you get people to kind of correctly value things that are bad for them? Like somebody has to pick up trash or do very unpleasant work, and how do wages for that type of thing get set in a marketplace? So this is an example I just got from the internet of a fried tarantulas. How many people have had these? Okay, one. How is it? Good or bad? It was good, okay. Ask her afterwards. There's actually a story here also about adaptive coding, like Rory was talking about, which is apparently tarantulas came to be eaten when the Khmer Rouge occupied Cambodia because people were so desperate for food. They basically literally eat anything they could fry and eat. And so fried tarantulas got to be eaten. And then people realized, they're really what it is if you fry anything, it tastes really good, even a tarantula, according to our audience member. And so if you ask people, would you eat a fried tarantula, a lot of people say no, that you couldn't pay me enough money. If you ask my 9-year-old, oh yeah, of course I'd eat a fried tarantula. He probably would, just to show off. And so we're going to study something similar to this, which is but instead of asking people how much they'd have to be paid, we're going to say, you're going to have to eat this unless you pay us to get around it, right? Like you're stuck in this restaurant and all they have is this yucky stuff, but if you want to take a cab somewhere else and pay money, you can get better food. Okay, so this is a published paper, again, with Min Kang. And so what we picked was foods. We pre-tested a lot of foods because, food tastes are quite different. So some people might love cold jellied eels, and someone may hate them, or some might love durian fruit, and some might think it smells like gasoline and urine, which it does. And so we pre-tested foods which most people didn't like at all, but some people didn't mind them. And some of them were things, and they had to eat a certain amount, like wasabi, you eat in sushi, is a Japanese horseradish, but we had them eat a big glob of it, more than you probably would eat comfortably, the same with Tabasco, pig's feet. And we're just going to do the reverse study with backpacks and optical mouse. We're going to ask people, how much would you pay to not have to eat this food? And if you don't pay very much, and that trial is drawn, you're going to have to actually eat a little spoonful of this. And people were very compliant. We have a strong kind of honor code at Caltech, and when there are experiments, they understand that, if it turns out that you didn't pay enough to avoid pig's feet eating and you have to eat pig's feet, you please have to eat it. And just eat, they're not lethal doses. And we tell them, if you really don't want to eat this, just bid the maximum amount. You won't have to. So this is the average bid by food. And again, we replicate the same type of structure. In some trials, they're hypothetical. And in some, they actually are going to have to eat. And we're going to see if there's a difference. So each of these dots is one product, like pig's feet. And so what you see is the blue dots are above the 45-degree line. The blue diagonal, I can try to use my laser pointer. The blue diagonal is if the hypothetical bids equal the real bids, but they don't. Typically, the real bids are higher than the hypothetical bids for almost all the products. So that means, for example, people are saying, pig's feet, that's not so bad. Yeah, I'll pay like $1.50 to get around that. I wouldn't mind if I have to eat it. But then it's like, oh, by the way, you're going to have to really eat the pig's feet. Oh, pig's feet, yuck, $2.50. So when it somehow sinks in their brain that they're going to have to actually eat this, that generates stronger neural processing and higher bids. Okay, so again, if you use these hypothetical questions about, how bad would it be if there was a prison built near your house, or how awful would it be if there was something that people don't like, you may get the wrong answer. They may get the wrong answer. And these are the areas. This graph is not quite as simple as the others, but these are a lot of areas in the brain that were more active in the real condition versus the hypothetical condition. And this is activity for better food. So these are things with low bids to avoid because the foods aren't really that bad. And if you, this is, again, not easy for you to see, but basically the activity here is very similar to regions we saw in the previous study. There's additional activity in ventral striatum and medial orbitofrontal cortex, which are kind of reward-related areas. And there's also additional activity in amygdala, which is a region that's important in kind of vigilance and fear and sort of negative processing of negative bad things. So the brain is basically more active when you actually think about having to eat these foods. And again, in principle, you could use this as a marker. If you were trying to get people to tell you sort of the truth about hypothetical bad things that might happen to them, you might want to use knowledge of the brain to do that. A very interesting practical question. We haven't really cracked this, but we haven't tried too hard. But we're cautiously optimistic is, the really interesting thing is when somebody says hypothetical yes, I will vote, or I will donate, or I will buy your brand new Apple Watch. Are they going to change their mind, and when the thing really comes out, or you call them up and say, we need the money you pledged, or now it's election day, will they change their mind and change their hypothetical yes to a real no? That's what we'd really like to predict, because if we could predict when that's going to happen, we could calibrate all our opinion polling and we'd be in much better shape. And the answer we have so far is yes, just a little bit, a little bit. So we have an eye tracking study in which we show people, you can't see the products very well, but we show them a picture of a product like a watch and then a price underneath it. And we can tell by measuring with a camera where their eye is looking on the screen and for how long. And this turns out to be a very simple index. It's much cheaper and easier to use than a $4 million brain imaging machine. And it turns out that there is some differences in patterns when they're really shopping and they're going to have to really buy things, or when it's hypothetical and they're just kind of guessing. And the upper left, the top two on the left are where they're looking when they, in the real condition when they say yes, and where they're looking in the hypothetical condition when they say yes. And then what you see to the right of the equal sign in green is the differences in those heat maps. So the brighter the color, the more red it is. That means there's more visual attention in that area, all right, called a heat map. And so what you see is that when they say yes, in the real condition, they're looking a lot more at the product features and a lot more at the price, which is down below. So it's not the case that they look at the price and say, oh man, I didn't realize it was that expensive. Now I'm going to change my mind and say no. They also look at the product more. They're just deliberating much more. And on the bottom, you'll see the difference when they say no. And here, when they say no in the real case, they actually look less than in the hypothetical case. So it's not the case, for example, that when they're making these real decisions, they're always looking more. What it is they're dividing their time up. They're making a snap judgment no, and then the yeses, they're kind of really processing and looking more. And so we've found statistically that if you take the way they look at hypothetical decisions and you try to say, could we tell whether they're going to change their mind and switch from a hypothetical yes to a no, you can do that statistically a little bit, maybe just a few percent. Again, that could be important from a marketing point of view. Like Rory mentioned, sometimes part of behavioral economics is about is considering a very wide range of possible effects besides prices and information, some of which may be small in magnitude but very big in impact. So that's where we are for that. Final study on hypothetical and real was very beautiful from my friend Dean Mobbs at Columbia. So he's been interested in morality and fear and things like that. So in this morality study, people were given 20 pounds, and they're told there's another person in the other room. So one person's lying in a brain scanner in the middle. There's another person that's, I think it's a volunteer that works in their lab, but it's a real person, and they're called the receiver. And the person in the scanner can see their hand, and they can see an electrode is attached to their hand. And they're basically told, this person's going to receive some shocks. They volunteered, they've agreed to do it, but they're going to receive some shocks unless you give up some of your money. And the more money you give up, the more shock relief you can get. So this is meant to be a very stark, almost like philosophers, right? He'll have to pose these awful dilemmas. Well, what if you have to push a stick and so you save a trolley and 5 lives are saved and 1 is killed? Philosophers love these moral dilemmas. And Dean Mobbs said, we should have a real one. We should have people really do this. And so in one condition, they're told, imagine. We're not going to actually shock them. Just imagine what it might be like. Try to really imagine it. And in that condition, they show the hand, but no electrical thing. In the real condition, they show the hand, there's an electrode. And they take quite a bit of pains, and by the way, the person really does get shocked, and they take quite a bit of pains from it to understand that this is real pain administration. You know, it's minor, it's not going to actually scar them, but in fact, the fear is worse than the shock itself. Like worrying about the shock is a lot of the fear. And what you can see on the lower right is that the money kept out of 20 pounds, the people who are imagining keep 14.45. That means they're willing to pay £5 55p to help the other person not get shocked. But when it comes down to real money, it's like, well, I don't know about that. You know, this is real. This is a lot of money we're talking about here. Then they're only willing to sacrifice 4.23. So people are sacrificing modest amounts in both cases, but there is a hypothetical real difference. And where is that in the brain? How is it being processed? On the bottom, you see areas of brain activity for both the real things, where the person is getting shocked, and the imagined. And you see a lot of activity in what's called the insular cortex, which is kind of part of the body's ambassador to the brain that helps us feel pain and imagine pain and other body sensations. And the middle cingulate cortex, again, a kind of executive function region, and some other areas. At the top, you see, you know, what's extra active when they know the guy's going to get really shocked versus imagining shock. And you see two regions. On the right, it's bilateral amygdala. Remember, we talked about that area before. That's, if you're about to get a shock, you'll have activity in amygdala. If another person who's a loved one is about to get a shock, you'll have activity in amygdala. That is, when you say, I feel your pain, I mean, that's kind of literally what the brain is doing. And the other area on the upper left is called temporoparietal junction. That's part of what's sometimes called the theory of mind or mentalizing area. So that's active when you try to imagine what another person might intend or might want or what they're going to do. And so, again, the moral of the story here is that they're not giving you exactly the right answer. And remember, people aren't necessarily lying, right? We don't say they're lying. What it is, you know, when they're imagining giving up money to avoid another person's harm, you know, they think it through and they do give up some money, and there is a lot of brain processing in common, right, on the bottom. But there's additional activity as they think about the other person and they think about pain that you get in the real condition. And by the way, Dean is famous for another study on fear. So there are a lot of studies on fear using shocks. He wanted to do something more dramatic, so he's the first person to do this. He got people who are afraid of spiders, and he has them lying in the scanner, and he has a tarantula, a real tarantula, and he brings it close to their foot. It doesn't touch them, because being close is bad enough. And again, what happens is that you get a lot more activity in fear regions, including the aqueductal gray, a very kind of old, phylogenetically old part of the brain that probably controls fear in many, many species, including ours. And you get much more activity there when there's a real tarantula as opposed to kind of a picture of a tarantula. And so he and I have been kind of pioneers of trying to say, you know, asking people hypothetical questions is useful and kind of necessary for a lot of things. Their future health states, moral trade-offs, whether you're going to vote in an election that isn't being held right now. But we'd also really like to understand when people are going to underreport or underfeel the feelings that are associated with those decisions. And we're starting to get a grip on this. Not everybody thinks this is such exciting research. This is a review from a grant at National Science Foundation in the US, kind of like ESRC here. And so this was a study to basically do some of the studies I showed you before, to use brain imaging to study how people value things. They said, this is all too much to take seriously for presumably well-respected scholars. I like that part, right? They weren't even sure well-respected. Either they're totally carried away with their technology or have been reading too much science fiction. And actually, it turns out my co-author, Antonio Miguel, does like science fiction, so maybe he was reading too much science fiction. Anyway, happily for us, we did get this grant, even though this was a poor rating. That's the lowest on the scale. And it funded some of the research you saw. So this research is quite controversial, even within economics, and not many people are doing it. Second part, I think this is even closer to behavior change, and there are a couple of, I think, nice insights here from just these two little studies on sunscreen and smoking. So here's a tan line picture. This was put out by a PADI, which is a scuba diving group, and they were interested in suntan lotion you can wear, and it would last if you scuba dive. So this is just tan lines from typical summer activity. If you don't wear any sunscreen, this is what you look like after you're water skiing or playing tennis or something like that. And you notice the pasty person second from right, computer programming. There's no sun there at all. He's from Caltech, okay. So these are two studies from Emily Falk and also Matthew Lieberman, her collaborator at, her mentor at UCLA. These are really great studies. So in the first study, what they did is they just showed people a bunch of videos and pictures of sunscreen. They were like little videos of people saying, you should really use sunscreen because you won't get skin cancer that way, and blah, 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 blah. And they picked out 2 areas, shown in the little white squares, 2 areas of the brain. One is called posterior, like in the back, cingulate, and one is the medial frontal cortex, medial in the center, frontal obviously in the front of the brain. They picked those out because in a study several years ago, those were found to predict kind of motor activity. They predicted whether somebody would press a button even before the person themselves said they had planned it. So that's not as strange as it sounds. What it means is that part of the body is sort of preparing to make a motion even before it's kind of consciously realized. And so they picked those out from a different study. They weren't fishing around here. And what they found was as people were watching these sunscreen ads, if you looked at the activity in those 2 regions, I think, yeah, the one that she's showing here is from the front, the medial prefrontal cortex in the front of the brain, like just kind of above the eyebrows. If you looked at across people at how much brain activity they had in that region when they were watching the sunscreen, that predicted how much sunscreen they actually used a week after the experiment. Now, how did they know? When they left the experiment, they said, we're interested in sunscreen use. That's what this is all about. And by the way, you know, in your kind of swag bag, we have a little brochure about our studies, so you can ask us questions if you want to, or call us, and a little, you know, a UCLA mug and a pen. And also, you know, we gave you some towelettes if you want to use more sunscreen. And so they call up a week later and say, remember those 7 towelettes we gave you? How many have you used? And so the people who used a lot of towelettes, that's on the y-axis of the graph, that's behavior change, actually had more brain activity when they're watching the movies. And the important thing is, it's kind of snuck in the slide, hard to see. This is controlling for attitudes and intentions. So that means that after the experiment, they told them, do you plan to use more sunscreen in the future, yes or no? And you know, how do you feel about using sunscreen? Like, does it make you kind of happy, or is it kind of gross? They use what they call a thermometer, which is just a 100-point scale. So what this means is, even controlling for whether people said they'd use it or not, their brain was telling us who's going to use the sunscreen, above and beyond their reported intentions. Right? That is, they're having some kind of visceral sensation that's telling you what they'll actually do. And upper right is the same picture I've just reproduced. And in addition, there's other activity besides what they first picked out in different brain areas associated with behavior change. Again, this is controlling for how gross or cool they thought sunscreen was and whether they said they'd really plan to use it or not, controlling for conscious claims about use. And I'll draw your attention on the right to motor cortex and pre-SMA, that's called supplementary motor area. That's like the second area for motor. And so what this means is that when people are watching these sunscreen ads, the people who are going to end up using more sunscreen in the next week have more activity in motor regions. That means, I think, that their brain is somehow imagining what it would be like to apply this sunscreen. So this is a big clue, right? If you want to get people to use more sunscreen, telling them it's going to prevent skin cancer may help a little, may not. Giving them free towelettes may help a little, it may not. Like with drug compliance, like Rory mentioned, you have to get them to, you can't just give them the stuff, you have to get them to put it on. But maybe, you know, what this suggests is that having them mentally simulate the process of putting it on or something else is sort of a key. The people who do actually intend, they are going to, beyond their conscious claims, oh, I'm going to do it. These are people who said, I don't think I would put on sunscreen, but they do, because somehow the motor cortex was kind of warming them up. And final study, also from Emily Falk, is they showed people some quit smoking ads. These were 3 ads that were actually going to air on television that encouraged people to quit smoking and to call a particular hotline. Call this hotline if you need help quitting. 3 ads. They're ads A, B, C. So on the lower left, what you see is they scan people's brains when they're watching the ads. Okay? And then they asked them, which of these do you think is more effective? And people said B. I think A is going to be okay. B is probably the best. C, nah, I don't think that's going to work. So those are the conscious reports. Usually that's the typical marketing data you might get, right? You ask people, how effective do you think the ad might be? Then we measure brain activity in this medial frontal cortex area. It's very close to the region that we also saw from sunscreen, which we think of as associated with complex valuation, like integrating complicated things like skin cancer and looking good at the beach, or dying of lung cancer, or looking cool smoking a cigarette. And it turns out that the brain, if you ask the brain which ads are going to be effective, it gives you a different answer. The brain activity says C is the best, then B, then A. So their conscious effectiveness is, I think B is going to really work. The brain said, no, 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 sorry person, sorry conscious interpreter. The medial prefrontal cortex announced that C is going to work. And then the cool part here is the behavioral variable is not from these subjects. Then they looked at how many people called the quit lines, not just these subjects, how many people called the quit lines when these different ads were shown. That's really what you'd like to predict, right? Is from a few brains you might like to say, can we kind of focus brain group these brains and then say who's going to call the quit lines? And the answer is yes. So the quit line call volume matched very nicely with the brain, but not with the effectiveness ratings. Okay, so again, these are just two examples, and obviously I picked successful ones, where the brain is telling us, something quite different about what's going on that's leading to actual compliance, sunscreen use, or quit line calling. And so decisions occur in the brain. Any argument about that? Okay, no, you're going to lose that one. We can measure some aspects of decision-related activity. I mean, I hope I convinced you at least with a few studies that that's possible. And as a result, if there's decisions that are kind of recognizable mistakes, like I say I'm going to vote, but maybe the brain evidence could recognize those mistakes. Again, mistake may not be the right word, but people are over-reporting an intended future activity, right? Whether it's a good activity like going to the gym more often or using sunscreen, or a bad activity like gambling or choose your favorite vice or smoking. So maybe we could use the brain evidence to kind of recognize when these mistakes are likely to happen. It also tells us, like in the case of sunscreen, that motor activity as people are watching these ads, it seems to be what's kind of crucial in determining beyond intentions whether people use the sunscreen. And hopefully, and the reason we do this basic research is eventually to be able to engineer. Caltech, we're interested in science and engineering, so we always. I'm not an engineer, a social engineer, but many of you are. And the idea is that if we are either a regulator or working in business or in NGOs, the idea is the more we understand about the very basic neural circuitry of some of these areas in which people say they plan to do wholesome things and they don't do it enough, or they say they're going to buy stuff and they don't buy, we can then understand how to change behavior and help people make the decisions their brain really wants them to. Okay, thanks.
Thank you very much indeed. We needed you really for our last election, which was a case where
yes.
Opinion and behaviour diverged
way
quite
off.
significantly.
Correct, yes. Correct.
And funny enough, we were having a conversation yesterday saying that historically marketing, if you look 20 or 30 years ago, was most marketing money was expended on things like, say, shampoo or packaged goods in categories where you had to buy anyway. You were at a supermarket, you'd run out of shampoo. And so in those cases, you might argue, well, maybe stated opinion isn't a bad predictor because the behavior is taken care of. Whereas what we look at now, if you look at marketing today, the vast majority of marketing challenges are persuading people to do things they don't actually have to do,
right.
where there's no crux point. So taking up high-speed broadband, for example, or life insurance or whatever. Those are things where you can actually indefinitely postpone them. So understanding likely behavioral activity and how to generate it is a much, much bigger proportion of our challenges than it would have been in sort of the Mad Men era. But I think, no, I don't think anybody there in the audience fails to see the significance of this. So when I said on Twitter that to explain the difference between the exit polls and the opinion polls, that the parts of the brain that do the talking aren't the parts that necessarily do the voting.
Yes.
That wasn't totally bad neuroscience.
That's
I'm
right,
really glad to hear that.
That's a pretty good translation.
Okay. I think the importance of that in both being able to predict and, of course, in being able to evaluate advertisements. It also explains, I suspect, why successful advertisements often had little motor cues in them of some kind or another, showing the action being performed. But that is absolutely fantastic. Can we, have we got we've got time for one question. Are you happy with that?
Sure.
Just one? I mean, if anybody, lady there, fabulous.
Hi.
Just very loudly if you can.
Loudly, okay. My name is Maria. I'm from McGill University. I have a question actually. Was there any interesting differences between the female and male brain, and more specifically in the electroshocking experiment?
That's a very good question. I'd have to double check that paper. Many of these experiments, as in early medical research, we often use, say, only one gender, because we think there could be a gender difference, and often we don't have enough statistical power to find it. So until you go further along. But there are some other very interesting studies indicating a male-female gender difference in shock propensity, but it has to do with whether you're kind of punishing somebody who's sort of been bad to the group. And it turns out that when women are asked to punish somebody who's been a free rider, who basically hasn't helped everybody out when everyone was helping them, women have a little bit of what we think of as empathy, even though it's a bad guy, and they don't like to punish. Men have no empathy, measured by insular cortex, and they actually see activity in the reward region of ventral striatum. So it looks like, this is one study from Tanya Seger, it looks like there is an interesting difference that, in the sense that men are more natural-born kind of social policemen. Men are less empathic and more likely to think, you know, even though this hurts you, you're really getting what you deserve, ha, ha, ha. And women are more likely to think, no, I don't know, maybe I should forgive you. Again, it's one study, and I don't want to overstate the stereotyping. And I should say, neuroscience as a field is quite keen on gender differences because we're going to find that some of the things that are quite stereotypical really aren't quite there. And other gender differences will emerge that are really more genuinely biological and kind of more interesting.
That's absolutely fantastic. You could be reassured if you're from McGill that the Canadian brain is significantly more generous.
Nicer.
Yeah, absolutely.
Oh, yeah.
Much more polite.
Yeah, this politeness area.
Exactly.
Right?
Huge politeness area in the Canadian brain.
Oh, yeah. Oh, yeah.
Oh, yeah. Thanks, that was fantastic. Thank you very much indeed.